Hello everybody, welcome to AP Calculus. This is Flip Math's practice of Unit 2, Lesson 10. This is the last and final lesson of Unit 2. And it's a pretty straightforward one. You're going to see some concepts that are just a review of everything you've learned in Unit 2. And you're also going to be specifically practicing some trig derivatives. Okay? So you should know the derivatives. I'm just gonna solve these. Um, at this point, you should know the derivatives of all of these. So let's get started. dy dx equals derivative of constant is 0. Derivative of cosecant is negative cosecant cotangent x. So if there's a negative, it's gonna be positive cosecant cotangent x. Okay. Next question. H prime of x. Well, we have a power rule, or product rule, sorry. So this is V, this is U. V U prime plus U V prime. Derivative of tangent x is secant squared x. So this is 2 tan x plus 2x secant squared x. Okay. Next one. We have r equals sine theta over theta. I'm not sure why this question is in here, as you guys haven't learned related rates yet, but I'm just gonna tell you that it's just dr over d theta, right? So we're gonna find a derivative with respect to theta. So we have a quotient rule, right? VU. So we get V U prime minus U V prime, right? Derivative of theta, which is, x in this case, derivative of the variable by itself is this one over theta squared. So uh, theta cosine theta minus sine theta over theta squared. Zoomed in a little so that I can make things a little bit neater. Okay, so VU, it's a quotient rule problem. So g prime of x equals v u prime. Derivative of cotangent x is negative cosecant squared x minus u times v prime, which is just 1 in this case, over x squared. So negative x cosecant squared x minus cotangent over x squared. Next problem. F of x equals 1 over 2 cosine x. So instead of doing quotient rule, you could also just turn the cosine x into a secant x by moving it into the numerator. So f of x, remember that cosecant is 1 over secant. Secant is 1 over cosine. So you have 1 over 2 cosine. So you could rewrite this as, oh no, the 2 stays in the bottom. So 1/2 secant x. F prime of x is 1/2. Derivative of secant x is secant x tan x. Okay. Pretty simple, right? Okay. Dy dx, this is a product rule, so VU. So V U prime plus U v prime derivative of secant x is secant x tan x. Okay, that is pretty much it for the simple questions here. These next couple of problems are the same exact thing, but now we just have to find the derivative at a point. So f prime of x equals 3 times tangent of x. So derivative of tangent is secant squared x. Okay, and then f prime of 2 pi over 3. So we could write secant squared x as cosine squared x, right? So 3 over cosine squared of 2 pi over 3. Okay. Cosine of 2 pi over 3. So unit circle. 6, 4, 3, 2, 3. So that should be negative 1/2. So negative 1/2 squared. 3 over. And it's computer. Okay. 3 over 1 over 4. So that should be 12, right? Because dividing by 1/4 is like multiplying by 4. Okay, next we have to find derivative of 2 secant x. So derivative of secant is secant x tan x. Okay, I'm going to zoom in. Okay, so f prime of pi over 4. You always want to try to rewrite in sine and cosine just because those are easier to, unless you're just a master of the unit circle. I mean, you just know secant x, cosecant x, the values. You should be doing this in sine and cosine to make it easier. So 2 over cosine pi over 4. Then we have a tangent, right? So rewrite tangent as sine pi over 4 cosine pi over 4. Pi over 4, that's square root of 2 over 2 for both sine and cosine. So 2 times square root of 2 is square root of 2. And then square root of 2 over square root of 2. Square root of 2 times square root of 2 is 2 over 4. So that is 4 square root of 2 over 2. That is square root of 2 square root of 2. Confusing, I know I probably said some things that were strange, but I think you get the picture. Next question, f prime of x, we have to do product rule. So v u prime. So v u prime plus u v prime, derivative of cotangent is negative cosecant squared x. Okay, I'm going to rewrite this in sine and cosine. So cosine of pi over 6 over sine pi over 6 minus pi over 6 times 1 over sine squared pi over 6. Now that's a lot, but bear with me here. Cosine pi over 6 square root of 3 over 2 divided by 1 over 2 minus pi over 6. 1 over sine, okay, so sine squared pi over 6 is, so sine pi over 6 is 1 over 2. 1 over 2 squared is 1 over 4. 1 over 1 over 4 is 4. Square root of 3 over 2 divided by 1/2 is just square root of 3. Negative pi over 6 times 4 is going to be just reduced down to negative pi over 3. And there you have it. questions 10, 11, and 12 require a calculator, so make sure you have that. So we're gonna use a calculator to find a derivative at a point. So our first function is f of x equals sine squared of x over 5 at x equals 1.8. So math 8, remember from a couple lessons ago, math 8, and then we have sine, so we're going to do parentheses, sine, and then x over 5, parentheses, parentheses, square the whole thing, evaluated at 1.8. So we're going to get x is 0.13, 0.131. Next, f of x equals cotangent of x squared over 2 at x equals -1. So what I'm gonna do is, so first, obviously, we have to do math 8. Then, write the constant first. So 1 over 2. Then, you multiply. Cotangent x squared. I don't see a cotangent button on my calculator, so I know I have to write it in terms of sine, cosine, or tangent. So cotangent is just 1 over tan. So I'm going to do 1 over tangent of x squared. And this is going to be evaluated at -1. So our answer is 1.412. So x, oh, this shouldn't be x. This should be f prime of x. So hold on, let me rewrite that. F prime equals that, and f prime equals 1.412. Our last one of the calculator is going to be f equals 3 secant of e to the x at x equals 2.5. Again, we don't have a secant on the calculator, so we're going to have to do some manipulation with sine or cosine. Secant is equal to 1 over cosine. So 3 times 1 over cosine of e to the x, parentheses, at 2.5, yeah, 2.5, and that is going to give us negative 15.922. Alright, next questions we have to solve for the equation of the tangent line and the normal line. And at this point, you should be pretty much masters of tangent line. So we're going to find our y value. And again, we want to try to make things easy for ourselves and write in terms of sine and cosine. So 1 over cosine pi is just going to be -1. Right? Cosine pi is -1, so 1 over -1 is -1. Now we have to find our dy dx, although I'm not sure if y prime is just like better to write it as y prime. So y prime of pi is going to be, so secant, right? Secant x tan x is our derivative, so secant pi tan pi, that is equal to 1 over cosine pi times sine pi over cosine pi. Sine pi is 0, so any 0 divided by anything is going to be 0. So y equals y1 plus our slope, which is 0. So since our slope is 0, everything else will be 0. So y equals -1 is going to be our slope, our tangent line. Our normal line, it can't exist. Simply, well, you could write x equals pi, right? Because, okay, so let me graph this. So y equals -1 is right here, and if you remember, the normal line is perpendicular to the tangent line. So although you can't get the reciprocal of 0, perpendicular line works. And this would be at pi, right? Because the x is at pi. So I guess x equals pi does work in this case. Okay, next problem. Y of pi over 3 equals sine pi over 3 over cosine pi over 3. Sine pi over 3 is equal to square root of 3 over 2. Cosine pi over 3 is 1/2. Square root of 3 over 2 divided by 1/2. Square root of 3. Y prime equals secant squared x. Y prime is 1 over cosine squared x. Cosine of pi over 3 is 1 over 2, so 1 over 2 squared is 1 over 1/4 is 4. So y equals y1 plus slope times x minus x1. Normal line is same except the negative reciprocal of the slope, and that is your answer. Okay. Last two questions, the test prep. Evaluate each limit. So limit as h approaches 0 of tan pi over 3 plus h minus tan pi over 3 over h. So you remember the, I guess I'll just write it. So test prep, we have to evaluate each limit. And so remember this limit is in the form f of a plus h minus f of a over h. So this tells us that f of x equals tan x and a equals pi over 3, right? You plug a into x, you get tan pi over 3, which is your f of a. So now we have to find f prime of pi over 3. So f prime of x is secant squared x. F prime of 3, we're going to write this in cosine. So cosine squared of pi over 3. Cosine pi over 3 is 1/2. 1/2 squared is 1/4. So 1 over 1/4 is 4. So that's our answer. For the next problem, we have the same form, right? So secant x is your, and this is pretty annoying. So secant x equals f of x. Secant x equals f of x, right? And then pi over 6 equals a. F of a is secant pi over 6. So f prime of x, the derivative of secant. Derivative of secant is secant x tan x. So f prime of pi over 6, which is our a, is 1 over cosine pi over 6 times sine pi over 6 cosine pi over 6. 1 over cosine pi over 6. Cosine pi over 6 is square root of 3 over 2. So 1 over square root of 3 over 2 is 2 over square root of 3 times sine pi over 6, so times 1/2 over 1/2 over square root of 3 over 2. So I'm going to go down here, 2 over square root of 3 times 1/2 divided by square root of 3 over 2. And this cancel out, so 1 over square root of 3. So you get 2 over 3. I hope this lesson was enjoyable. It was a quick one, very quick one, and it was pretty easy. And Good luck on your unit tests. Uh, Unit 2 is a pretty nice introduction to calculus. So, hope you enjoyed and take care. Good luck.